Okay, I think we can start our workshop on shell scripting. Okay, so this workshop is conducted by NUS Hackers. So it's part of our Hackerschool. I'm sure you guys all know. So I'm your speaker today. My name is Sai. I'm a year 2 CS undergraduate, and I like playing video games. So I'm sure many of you know Silk Song just came out. So I'm very excited to play that, and I'm sure many of you are excited too. I also do watch anime in my free time. So during this workshop, if you all have any questions along the way, you can just ask me. It's quite basic, so I'll keep it slow and stuff. But again, you can just feel free to stop me along the way if there's anything. So what will you learn today? We're going to cover how to use the shell and how to create like some basic scripts for automation. So we'll start with like a brief introduction to Unix and Unix-like commands. And then after that we'll go into like how you can use scripting to do stuff. So I hope all of you all have like downloaded like at least one of these. So if you have Linux, you're obviously good, or Unix-like OS, you're also good. WSL is also works well. I'm using WSL today. Mac OS is probably fine too. So anyone have any issues with setup or anything? Okay. Okay. What is Unix? We'll start with a brief introduction of it. Unix is a family of like multitasking, multi-user operating systems. So I guess a common misconception for many people is that like they think Unix itself is an operating system. But actually, it more so refers to the family of operating systems. It's built quite a while back in 1970, and it both popularized and is popular for its heavy use of the command line, which is all we'll cover today. So the main Unix philosophy is the three-step philosophy. The first is to write programs that do one thing and do it well. The second is to write programs that work together. And the third is to write programs that handle text streams, because that's like the most universal and general interface. So today I hope that in the workshop you can see how all these three things come together. Okay, so with that in mind, let's get started on shell. So shell is a very efficient textual interface to your computer, and it provides an interactive programming language called scripting. So at this stage, you all can probably open up your terminal. Give me a second. Okay, so okay. I hope you can see. So basically, most of your shells should look like this. So you see the dollar sign, and this is like the classic image of how a Unix shell will look like. Oops. So there's many standard shells to choose from. The standard ones are, of course, things like shell or bash. There's shells that can match specific languages like CSH, and there's also better shells like fish, ZSH. But for today's workshop, we'll mainly focus on shell and bash. So I mean shell being SH. So as mentioned, when you first open your terminal, you should see something like this with the dollar sign, and that should let you run various programs and commands. So maybe we can start with some like common commands and what they do. Okay. So I'm sure many of you know like from a terminal, the first thing you like to do is probably like change your directory and then navigate around the computer, right? So to do that, you can use cd, which essentially stands for change directory. So if I do something like change directory to a certain path, so for example, user/bin, which is just some random part of my computer, or cd mnt/users. Or cd/mnt, for example, it'll change my current working path it'll change my current working address to /mnt, which is, you can see by this highlighted part here, /mnt. On the other hand, if I do cd tilde, it'll basically take me back to the home, which is the root. So now I'm back in the home. Another useful command is ls. So ls stands for list. So this basically just shows you the list of all the folders, all the files you have in your current directory. So there, for example, let's say I want to go into the shell scripting folder, I can do cd shell scripting. And a good like shorthand is if you press tab, it'll help you autocomplete. So now I'm in shell scripting. Other useful things is if you do cd dot dot, it'll take you one directory. It'll basically take you up to the parent directory. And if you do cd dot dot slash dot dot, it'll take you up to parent directories, so on and so forth. There's also other commands. So there's man. So man essentially gives you, so man is important because it helps you figure out how different commands can be used. Man essentially gives you the manual for a specific command. So for example, let's say I want the manual for the manual command. I can do man. Okay, it's loading. And you can see here, it gives you essentially a full instruction on how to use man, as well as its description, use cases, and all of that. So you can do that for pretty much any command that you need help with. So here's a list of some common commands. So as mentioned, we have man, we have cd, which is to change a directory. We have ls, which will list all files and directories inside your current working address. Other useful ones are mkdir, which basically just makes a directory. rm, which removes files and directories. Copy, which copies a file. Move, which moves a file. So maybe I'll show you some of these. So let's see, I go back to my terminal. You guys can follow along. If you have any questions, just ask me. So let's say I'm in my root again. Then I want to make a directory called like test directory, for example. I can do make directory test dir. So now if I do ls again, you guys can see that the test directory has appeared here. Now if I want to cd into test directory, I can just do this, and now I'll be inside the directory. Now let's say I want to like create maybe some like file, for example. I can use my whichever text editor I want. Maybe I can do vim. Let's say I want to call the text file test1.txt. Then I can just type something here. And if I do ls again, now you'll see that test1.txt appears inside the folder. Does everyone kind of get that? So basically the idea is we created a directory, we moved into it, and then we created a file inside it. Now if I want to maybe move this test1 into a different directory, I could do move test1.txt, which is the path to the file I want to copy, and then the address where I want to copy it to. So let's say I want to move it. Let's say I want to move one directory up. So like when using the terminal, right, it's always using the path to like the arguments in this case would be the path to where you want to move it to. So if I want to move it to one directory up, I would just do dot dot, for example. So if I do that, if I go outside, now you guys can see that test1.txt has appeared here, right? And then if I want to move it into shell scripting, I can do move test1.txt into shell scripting as an example. So if I cd into shell scripting, you'll see that test1.txt has now appeared here. Okay, does everyone kind of get that? I think like don't you focus on the details of the commands too much, but this is just some basic intro. So just how the move command works. So another useful command is rm. So you can just do rm and then the path to the file you want to remove. You can do cp, which works very closely to move, except it just makes a duplicate of the file. And you can also do pwd, which basically prints your current working directory, which is basically the place where you're currently at. So for example, from here, if I type pwd, basically it just tells me the full path to my current address. There are also some like Bash also like, since it's very like keyboard friendly, it also has a lot of shortcuts that you guys can use. I don't think I'll be showing all of them, but like here's a list of them, like most of the most useful ones. So for example, if you do Control+A, your cursor will immediately shift to the beginning of the line. Control plus E will shift it to the end of the line, and so on and so forth. You guys can just take a look at these. But I think it's not too important for now. Okay, these are some more important ones. So if you ever like have a program that's maybe like running non-stop or running on an infinite loop in your computer and you need it to terminate, you can press Control C. So I'm sure like if any of you have had like an infinite loop, you've probably done this before. Control Z is kind of similar, but it doesn't terminate the command. Instead, it just suspends it. And we'll go into the difference of this later. Control plus L clears the screen. You can also just type clear, which achieves the same thing. And then there's a few more, which is Control plus S, which stops output, and Control plus Q, which re-enables output. So there's actually some very fun commands here, fun in quotation marks, that are very notorious. And hopefully by the end, you guys can understand more about why exactly they do what they do. But the first one we can explain later, but the second one, essentially what it does is RM meaning remove. RF we'll explain later again, but it basically deletes everything in your working directory recursively, including your operating system. So don't run these commands. Okay, so like does anyone have any questions so far about like just the basic intro to shell? If not, we'll get started on like the more like scripting focused stuff. Okay. Okay, so when it comes to shell scripting, right, you can either write programs directly at the prompt or write into a file. So today we'll be using them interchangeably, but just to let you know that both are an option. So for example, say I go back to my terminal. So if I change to root, so a very basic shell command is echo, which basically just prints out whatever you type after it. So if I do echo hello, I only see that the first thing that comes up is hello lah. If I do echo hello 2.5, for example, then the same thing comes up. So when you open the terminal itself, it's already running a shell interpreter. So you can start executing these basic, you can start executing all shell commands immediately. But if you want to store it in a file, you can also open a text editor of your choice and then start typing the commands there instead. So you could do nano test.sh, for example. Then let's say here I type in the same command, echo hello. Okay, then after that, once I save it, so now that you've done that, you should see a file called test.sh in your directory. If I then do /test.sh, oops. Okay, so you might run into this issue, which is that you get permission denied. So to see why this is the case, you can run this command, ls.al test.sh. So the interesting thing about Unix-based systems is that when they, unlike Windows, which can run almost any type of executable, for a Linux-based system for a Unix-based system to decide whether a program is executable or not, it looks at the permissions associated with that file. So what it specifically looks for is an executable permission. So while this is not really legible right now, what you're looking for is there should be like an X, which will represent that it is executable. So we need to change the permissions of this file to make it executable. So how do we do that? We can use the chmod function. So chmod just changes the permission of the target file. So I'll do chmod add executable, which is marked by +X to test.sh. All right. So now if I run the same ls command again, I want to see how now it's rwxr, which now means that this file is executable. So now if I run /test.sh, it'll hello. Does everyone get that? So the main thing is like, just when you create a file, it doesn't mean that you can execute it immediately in Unix. You need to first change the permissions as well. So another interesting thing is, while this file is coded as a test.sh file, let's say I renamed it. Okay, so now the file is called test.py. Okay, does anyone think it'll still work if I try running the test.py file? Did someone say no?
I say yes.
Did someone say no? Why do you say no? Okay, good guess lah. I mean, in Windows, this obviously won't work lah. I mean, because it's a py file, then you have like random ass shell code inside. But actually, surprisingly, if I do run it, sorry, /test.py, it actually works fine, because the way the shell is deciding which interpreter to use is quite different in Unix. So let me explain this more. So let's say I open up the file again. So we can use this concept called a shebang to explain this. Let me go back. So let's say I put something else at the top.
Exclamation mark is 1. Small p.
Is it small p?
I think so. I'm pretty sure.
Okay. So sorry, I made a typo just now. Oops. Okay. So I want you guys to see what I added at the top. So I added this thing called hash exclamation mark blah 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 blah. So now if I try running it, get error saying that I cannot execute the required file. So now let me try changing it to Python code instead. So let's go vim.
Edit the Python to Python 3 to Python.
Oops.
Do you not have Python?
I do. Oh, sorry. 1 second.
Oops, you don't have.
Yeah. Strange. Okay, sorry, my bad. I made a small typo in the file. Okay, so basically, right, the idea is I added a thing at the top, which is some weird syntax for now. But now when I try running it, I change the code to Python, it's able to interpret it as a Python file properly. Even now, if I go back, for example, say I go back, let's say I rename this to a sh file instead. So now if I try running it, so .sh, it still work. So the point I'm trying to make is that like the way it decides what interpreter to use to run the code is not decided by the extension of the file. It's decided by the thing that I put at the top, which is called a shebang. So let me open it again. Sorry, wrong file. test.sh. So in this case, when I put the exclamation, the hash bang and exclamation mark is a special syntax that you put at the top of a file that you want to use as a script, and basically tells you need to pass in the path to the specific interpreter you want to use for that file. So in this case, I passed in /user/bin/python3, which basically is me telling the shell to use the Python 3 interpreter to run this program. If I instead did something like if I change this to sh, for example, it wouldn't work anymore because now you try using the shell interpreter to run Python code. The reason why it worked at the start, even when I just put echo hello without any shebang at the top, is because by default, essentially by default, the default interpreter is chosen to be the shell interpreter. So if I don't specify anything, it will automatically choose bash. Okay, does everyone kind of get that? Okay, it's a bit confusing because okay, the syntax also I made a few mistakes lah, but essentially it's just the path to the interpreter you want to use, which can be Python, it can be by default bash or whatever lah. All right, so okay. So as mentioned, the hashbang exclamation mark is called a shebang. Shebang because like it's hash and then exclamation mark because it's like bang. So again, it specifies the interpreter that we need to use. As mentioned, echo is a very basic command that prints out its arguments to the standard output. And as mentioned, you can also pass in other interpreters like /user/bin/env space Python. Does everyone have any questions about this? Okay. So another, oops, sorry about that. Okay, so another important concept in most like Unix-based programs is flags. So most of the command line utilities take parameters in this form, and usually they come in either short form, which is -h, or long form, which is like --. So I mean, -h is the equivalent for -- help, and there's other examples which we'll cover later. So usually running a command with like command -h will give you like detailed instructions on how to use that specific command. And you can also combine short flags together. So instead of typing rm space -r space -f, you can just do rm space -rf to do them together. So another thing is that a double dash is used to signify like the end of your command options, after which only positional parameters are accepted. So for example, going back to my terminal, there's this command called touch, which basically creates a file of your whatever name you want. So maybe I can create a file called test file.sh. Okay, so now if I come here, there's a test file.sh. I can also do test v. Sorry, test. Sorry about test v, which basically just tells me the version lah. I mean, if you see, there's no file called -v here, because in this case, v is being taken as a flag to the test argument, to the test command. So you might question, like, in that case, how do I create a file called -v? That's where the -- like separator comes in. So I do test -v. Oops. Oh, sorry, my bad. Thanks. Yep. Yep. And now you can see that the -v file has been created. Thanks, whoever said that, by the way. My bad. Yeah, but anyway, now you can see basically the -- operator is used to signify that the next thing that you're passing in is not a flag parameter, but instead it's the name of the file or whatever, depends on the context lah, of the thing that you actually want to create. So there's some very like common flags that are like de facto standards. So -a is all files. So if you do like ls-a, it basically means list all files, including those that start with a period. Because by default, if you just do ls, files that start with a period, like for example .gitignore, will be ignored. Another common flag is -f, which you saw in rmrf, which basically means forcing something. So in the context of rm, it means to like force delete something. -h is help. Small v is like verbose output, which means basically give you more detailed logging, and big V gives you like the version of the command that you're using. Another important thing to cover is that Unix has a slightly different directory structure than. So unlike Windows, which has the concept of like a C drive or like different drives, in Unix everything is instead like in a hierarchical order. So everything is stored in directories instead. There's no like concept of drives. The root directory is just slash, and then from there it's like hierarchical going forward lah. And also compared to Windows, which uses a backward slash, Unix uses a forward slash. So some of the common, like usually in most cases, like always these will be quite similar lah. So slash bin and all of these generally slash bin, like basically all the first row can generally contain all your executables and that kind of stuff. Slash home contains your like home directories. Slash users is your user home directories. Var is your temporary, var log is your log files. Temp is your temporary files, and so on and so forth lah. Okay, so with that in mind, I think next we can move on to some basic shell syntax. So, okay, we discussed just now, echo hello is a very basic command that basically just prints out whatever you pass in. So echo hello will print out hello. But in general, most of the commands that we'll be working with today take in the following format. So it'll be the command name space our first argument space second argument space third argument. So arguments will be passed into the command to like to determine its behavior. I mean like to decide what it's going to do. So so for example here we have this echo location which will print. Okay, let me open my terminal again. So a very basic thing could be something like echo location, which will print location. Then after that, I could set the variable name to equal some certain string, for example, Julius. Now you might think, how do I actually access this name variable? Because if I just do echo name, it's just going to print out name, which obviously isn't what I want. I want to print out Julius. So instead what you have to use is you have to use the $sign, which will be here. And then now you'll get Julius. So when you want to like get the values associated with the variable, you have to prefix it with the $sign first. If not, it'll just be taken as like literally name, which is like not what you want lah. So there are also like other special variables, all prefixed with the $sign. So $sign question mark gets the exit code of the previous command. $sign 1 to 9 gets the arguments to a script. $sign 10. Okay, so this one is there's a typo here. If you want to get the arguments, if you need more than 9 arguments, so you need to access 10 onwards, you have to wrap them in curly braces. So it should be $sign, curly brace, 10, close curly brace. $sign 0 gives you the name of the script. $sign hash gives you the number of arguments. $dollar gives you the process ID of the current shell. So, okay, let's try creating a very simple script. So, say I open vim test script. So, if I want to like, let's say I want to create a program that takes in 3 arguments from a user and then just prints them out. What I can do is echo $sign 1, echo $sign 2, echo $sign 3. So basically, this is just echo out the first 3 arguments that the person passes in. So let's try saving it. Don't forget first you need to change the permissions. Okay, and then we can try running it. So let's say I pass in just 3 names, my name and 2 others. So see that it just printed them out. So if we go back to PDF, so there's also this $sign hash that you see at the bottom. So what does that do? Let's try. So vim script. So now the only change I made was I added the $sign hash at the bottom. So see, it prints out 3 because what the $sign hash is, it just equals the number of parameters that I passed in. like mm, um, then it'll be 4. Now there's 4 parameters instead. So I always notice that each of these like arguments are like separated by a space, and some of you might realize that there might cause problems, which we'll cover later. But for now, yes, each space separates one argument. So another important thing is a loop command, of course. So essentially it's used to run a specific command multiple times. So this is a very basic example. So then let's try unpacking this slowly. So the general the general structure of a loop command is for x in some list, do body, done. So we use the semicolons here to terminate each of the three sections, but you can also use a new line. It's equivalent. So what this essentially does at a low level is it splits list into whatever values it outputs, assigns each to x, and then runs body. So list will be split by the white space again between each term. And again, we'll get into this later. So for example, if I go back to my terminal, so instead I type seek15. So seek is a command that takes in 2 parameters and basically prints out all the numbers between them. So if I do something like, if I then do for I in $seek15, do echo hello, done. So basically, I took every value output by seek1 to 5, which is 1, 2, 3, 4, 5. And for each of them, it just echoed hello once. I can also do something like echo I, which will just again print I 5 times. If I do echo $I, then it will print the value of I. Does everyone kind of get that? So in the previous case, I did echo I, which literally prints out the string I. But when I put a $sign if I put a $sign before it, it treats it as the variable I, which again, as I mentioned, takes on the values output by the sequence 1 to 5. So therefore, the output will be every number between 1 and 5. Okay, does everyone kind of get it? So the loops are quite simple here. Again, it's just like literally 3 statements. The first is the range of the loop. The second is the thing that you want to do. And finally is the termination. Okay. So one important thing to note is that like everything in a shell script is a command. So like in this case that you saw how I could like run the seek15 command on its own. So I think that's the power of shell script. Everything is a command and everything pipelines into each other, which allows it to become very compact in a way. So here, as I mentioned, it means to run the echo command with the argument hello 5 times. All the commands used in shell scripting are searched in your path. So they should be able to be used directly in your terminal as well. And if you're interested in finding out where a specific command is located, you can try using which. So you can do like which ls, which will point you to the path to like the ls command. All right. Another important thing is conditionals. The syntax for this is a little bit longer, but it's essentially very, very close to what you expect. So it's if, then the condition that you're testing, then the statement, like if the condition is true, and then your else condition. So, but the interesting thing about this is that like unlike your normal if statements, which would check for like a Boolean kind of thing, in this case, since as we mentioned, like everything in this case needs to be a command, right? So instead, what the if statement checks for is whether the command passed in as the predicate is run successfully or not. So it looks at the exit code of the thing that you passed in. So example in this case, right? So if condition. So the condition here, what the if statement does is it checks whether the exit code of the condition is a 0, which is considered a success, which will then cause the body to run. On the other hand, if the condition fails, which means that the program, like the command associated with the condition did not run successfully, then it goes to the else statement. All right. So if you look at the example up here, we have if test space -d /bin. So what this is, the test is a program that essentially provides various checks and comparisons and exits with exit code 0 once the condition is true. So, and if I do test /d, what it's doing is essentially checking is /bin a directory. So basically what it's doing is if bin is a directory, then echo true, else echo false. So I think this is quite simple code. All it's doing is saying that if it's truly a directory, then print true. There's an alternative syntax you can use, which is the square brackets here. Or in specifically, you want to check that bin is the directory, you can use the -d. So square bracket -d, square bracket -d/bin. Another thing is also you could remember to check exit code using $sign. $sign, we can refer to the code slides from before. Okay, so one common use case that you guys might want to consider trying is creating a command like ls that only prints directories. So we can try coding this out. So let's open a list test.sh. So let's just follow the code in the slides. So for f in $ls, the Okay, this should be quite a simple code. Basically saying for f in $ls. So as we discussed, ls just lists out all the files and directories in your current wherever you are currently. So for each of them, it does, oops, sorry about that. Okay, so for each of them, it tests if it's a directory. If it is a directory, then it echoes out dir and then the name of the directory. So dir is incorrectly highlighted here, but it's basically just saying echo this statement. Then after that, just finish and done. Okay, so let's try running this. chmod plus x. Thanks. Okay, so how many of you guys think that this will actually work? Okay, like it's obviously not gonna work, I mean, if I ask the question. So, okay, wait, no, sorry. Rather, it does work in this case, but there's a problem with it, which we'll get into. But does everyone kind of see how it works? So basically, it looked through my current working directory. It checked which of them are folders, and then just printed them to the screen. So let me open the code again. Oops, sorry about that. Okay, so just a recap. So for f in the output of ls, which again lists all files and directories in your current, wherever you are currently, it tests if it is a directory. If it is, then it echoes dir and the name of the folder. Okay, does everyone kind of get that? Okay, so now let me show you a case where this will break. Let's say I make a directory called my documents. Oops, make your. Okay, now let's say I try running this again. So now I should expect my documents to also show up in the output by list test. But it's actually kind of weird, right? You see now how it's split up into, essentially my documents has been split into two, it's being incorrectly read as two documents, two files, two folders, sorry, which is my and documents. So the reason for that will be clear if I open up the code again. So ls again returns a list of all the folders and files separated by white space. Because remember, the way the for loop works is that f takes in every single value from the output of the ls, like they're separated by white space lah. So when the ls lists out my documents, then it also becomes split up. So we essentially get a case where f first becomes my, and then it becomes documents, which is not what we want, right? Because we want f should have been my documents, as because that's the name of the folder. So how do we get around this issue? So this. So okay, yeah. So as mentioned, for f in ls expands to basically for f in my space documents. Okay, but the issue is that essentially f first becomes my, and then f becomes documents after that, which clearly results in the bug that we saw. So bash splits all these arguments by white space, whether it's tab, new line, or just a space. A similar problem can be seen somewhere. A similar problem is also seen in test d $f, because again it'll be test d my space documents, which essentially is equivalent to passing in two parameters, one being my and the other being documents, rather than passing in my documents as one word. So if $f contains any white space, test will immediately error, which is not what we want. So the way like bash gets around this is by using quotation marks. So if you do for f in quotation marks my space documents, then it will treat it as a single word and it won't split it up anymore. So now f will take on the value my documents. But then we can't really do that in our script, because in our script we're using the output of ls instead. A very naive approach could be to do something like, okay. A very naive approach could be something to just do like, I just put a $sign here, a $sign here. So, okay lah. Does anyone think this will work? Okay, let's try running it. Yeah, okay, clearly it doesn't work lah. Line 4, too many arguments. Basically what this does is now it's taking the output of ls and it's putting it all into a single string, which is not going to work. And then here in test d, it then splits that up into, sorry, and then it just passes down to test d, which also does not work anymore lah. So what we don't want to put the entire output of ls into a single string. Instead we want each folder or file to be put in its own. Only the name of each file or folder should be put in quotation marks, rather than the entire output of ls. So what's the solution for getting around it then? So what we do to get around these kind of like issues with files and folders is we use this thing called globbing. So bash knows how to look for files using patterns. So this is kind of similar to regex in a way, similar-ish. But basically what it does is I can use this star operator to say, look for any string of characters in my current working directory. Question mark is any single character. And then the characters, if I just type in a specific letter, then it is actually the letter itself. So if I instead did for f in star, it means all files in the current directory. So when you do this globbing, each matching file becomes its own argument. So it becomes encapsulated in the quotation marks. But we still need to quote the test lah, because that one will still end up splitting my documents if we run into it. So let's try doing this. So I need to put quotation marks here. Let's say, so I need to replace this with a star. Right, so let's try running this. Okay, so now, oops. Is it? Oh. Oh yeah, my bad. Okay, so that's exactly, okay, good point. This is how bugs in shell script happen. Because when I did ls my documents, again, it's split up by white space, which created two folders instead of just creating one called my documents. So if I want to create one called my documents, I should put them in quotation marks. Wait, who said that? Thank you for the catch. Oh yeah, thank you. Make their my documents. Okay lah. So now we got my documents here. So now if I run it again, okay. So now we still got this my and documents from before lah, which is problematic. But now if I see my single folder called my documents also did show up. Okay, so it's quite problematic because clearly in shell scripting, the fact that white spaces are treated as the separation between parameters can trip a lot of people up. So it's important to know how to use these quotation marks and be mindful of them. So for the globbing, you can use advanced patterns as well. So sorry about that. So for f in star, basically just searches for all files or folders in your current directory. You can also do for f in a star, which basically just means find all files or folders that start with the letter A. So yeah, so all files starting with A in the current directory. You could do something like foo/star.txt, which means find all txt files in the foo subdirectory. You're going to do something as complicated as this: foo/star/p question mark question mark. So what this means is basically all 3-letter text files. So it must be 3 letters, but the second 2 letters can be anything. So it must start with P, and there must be text files in subdirectories of foo. So there are other white spacing issues as well, and clearly this is quite a big problem. So if you do something like if $sign foo equals bar, which basically is a simple equality check lah, checking whether this variable holds the value bar. The issue is that if you have a case where foo is empty, then the arguments to the square brackets, which is equivalent to test, becomes equal bar, which will create an error because the first parameter to the square brackets cannot be equal sign. So like one very hacky workaround is to do something like x $sign foo equals to x bar, because the x will always cancel each other out. So even when foo is empty, you'll still have an x left here. But I mean, this one's quite hacky lah, so usually not recommended. So instead, what people normally do is they use a double square bracket and condition. So this is the bash built-in comparator that has special passing. So it's very similar to the test operator, which is the square brackets, except instead it uses the double square brackets. It also allows for like your usual like logical operators like and or and so on. Okay, so as mentioned, the problems like these are the most common bugs in shell script. So there's a good tool to check for these kind of possible bugs. You guys can take a look at this link later. Okay, so I think maybe we'll take a break. All right. Okay, we can continue with what we're talking about. So the next important thing to cover is like composability. So this is like another important aspect of why shell scripting is like kind of useful and important. Okay, so what composability is essentially the fact that you can chain multiple programs together rather than creating one program that does everything. So this goes back to like the Unix philosophy of like basically every program should do one thing, but should do it well. But you can then like integrate them together to do like more complicated things. So, okay, this is like one example. Ignore what the commands themselves do for now. But the interesting thing is this like straight line operator. So what it's called a pipe. So essentially what this means is run, so okay, let's look at the example here. A line B. So it means run both A and B, but send all the output of A as input to B, and then print the output of B. So very like you can change this as long as you want. So like one example here is this. So what cat does is essentially looks at a file and then prints out the output of the file. So cat blah blah blah. Then what grep does is it basically matches this string, whatever's passed to it, from within the file. So you can think of here as cat will output whatever content is stored in this syslog file, which is then passed to the grep command, which will then search for any instances of sep10 in it, and then it will be passed to the tail. So tail just basically just prints the last 10 lines only. So the idea is like, with this way you can, so cat is only responsible for printing out. So cat is a command that's built in, so you guys can try this if you want. But cat is only responsible for printing out the output in the file, grep is only responsible for searching any matching hits and so on. Every command has its own responsibility, and it's a simple responsibility that can be tied together. A related concept that's important is the fact that all programs have three main streams. So standard in, which is where the program reads input from, standard out, which is where the program prints to, and standard error, which is the second output that the program can choose to use. So by default, the standard input is of course your keyboard lah, because you can like type into the terminal from your keyboard. Standard out, standard both your terminal, because that's where the output of the files, like the output of the commands are printed to. So there's a lot of different ways that we can do stream redirection. So as mentioned, we have A pipe B, which basically just means makes the standard output of A the standard in of B. So what this does is basically saying take the output of A and pass it as the parameters to B. There's also this like I guess a greater than like less than symbol lah, or okay lah, this right arrow operator, which basically just means that the standard output of A goes into the file foo. So this means it's basically anything that A outputs will be stored in the file foo. So I can give you an example of that. So okay, let's say I do ls. So again, I have all this, but let's say I want to instead store it in some file. What I could do is ls pipe list of files .txt. So now, if I open my vim list of files, you see that the output of my ls command has all been saved in this file. So that's what the arrow operator did here. Basically saying redirect the output of the first argument, which is ls, into the file that comes after it. So there's another one which is A, but then you put a 2 before the arrow. So this just means like instead of the standard out is the standard er. So this one is not that useful, but it's just good to know. In some cases, you also pipe in the input from a file. You don't just want to pipe the output. In that case, you can use the other sign arrow. So in this case, A arrow foo with the reverse sign tells that the standard in of A is read from the file foo instead. So whatever content is in the file foo is passed to A. There is A arrow arrow arrow, which basically just means that the standard in of A is read from what comes after the 3 arrows. So basically this just means like I could pass in like, this one's not that useful also, but I could pass in like a raw string, which would then be passed to A. There's this pipe to T, which we'll cover later if we have time. But if you're interested, you can look up in the manual what it does. So it's useful because it lets us manipulate like the output of a program. I can do something like, so let's say I go back to my terminal. So once again, let's say I do ls. And let's say I want to search for a particular phrase in the documents listed. I can do ls grep test. So you see now, basically what it's doing is this ls, which is listing all the output of the files in my current directory, and then the pipe operator, which is sending it to the grep. And grep, as I mentioned, basically finds all matches of the, since I passed in test lab, finds all matches of test. So, and you can see here, all of these are written because they all have test in their name. So you have list test, I have test.py, I have test.sh, so on and so forth. So the point is like it's kind of useful because again, like I mentioned, you can tie all the commands together. So there's PS, you can do PS, which basically lists all processes, and then again you can search for a certain command. This is another example. So the idea is again that basically with these few piping operators, you can essentially combine simple commands or simple programs into much more complicated things. Right. So there's also this thing called grouping commands, which is when you want to run 2 programs and pipe the output to another one. So in this case, you have this basically parentheses, one that says run A, then B, and send all the output to tag. Tag just means print in reverse. So for example, if I do, let's see. What? Oh, I didn't know. Apparently, so tag, like cat prints out the contents of a file. Tag is cat in reverse. So therefore prints the words in reverse. Okay, show you this. So say I did echo 1, echo 2, echo 3. So basically it's taking these three programs and three commands, executing them. Executing them and passing the output to the tag command, which prints them in reverse. So it prints 3 first, it prints 2, and prints 1. If I instead type in the cat command, then I get 1, 2, 3 lah, which is the correct order. So this is just another example. Sorry. Okay, so the next thing we want to cover is, sorry about that. So another thing that's important is this. Oh, no, this is not as important, but just, I guess, good to know. So there's also this concept of like using this parentheses around the second argument. So what this does is, this is more so for commands that need not the content of the file, but the path to the file itself. So what this means is basically run A, generate a temporary file name for its output, and pass the file name to B. So I'll show the output of this later, but basically again it means that B needs the path to a file as its argument, not the content of the file itself. So let's try this. So echo A. So if I run this, okay, so the first one is echo A, which is, so it's evaluated from right to left because it's the rightmost thing is passed forward. So first it does echo C with this notation, which essentially creates a file, right? So it's passing the address of this temporary file, and this temporary file contains the output of echo C, so just be C. And then same thing is done for B, which is also the path to the file. And then all of that is passed to the echo, the leftmost echo. So the leftmost echo first prints A. It prints the output of this, which is the path to the file, and prints the output of this, which is also the path to the file. Okay. So another useful thing about shell scripting is that it's very easy for you to run things in the background. In fact, all it needs is for you to put an ampersand suffix at the end. So if I run something like this, okay, let me try putting this out. So for I in $sign seek. Okay, so this is a very simple program that we looked at just now. Basically, it's iterating from 1 to 100, and then for each of them is just printing high. But if I add an ampersand at the end, okay, so if I just do this without anything, basically it's just going to print high forever. Not forever, 100 times. And I'm not going to have control of my terminal. I can't do anything while waiting for this. So let's say I end it. In most real world cases, you might want to let this run in the background while you continue doing other stuff with your terminal. So to do that, you can just put an ampersand here. Okay, and you see how essentially now, okay, it doesn't look like it because this thing is pushing it down, but I've re-gotten control of my terminal, and it's just printing high in the background. So I could still do whatever commands I wanted if I type echo test. You see, it still prints out test, but then in the background it's still running out. It's still continuously printing high, which is kind of annoying lah. And if you try pressing Control C, you can't end it either. So if you want to end it, you basically, when you first initiated the background process, it would have printed the process ID, which is here, 1356. So I can do kill 1356, which will terminate the process lah. Yep. So as mentioned, the running program, even when you put the ampersand, it goes to the background, but it still has your terminal as standard out. So if you want, in another case, you might want to redirect it to like a file, for example, which will not spam your standard out with like a lot of random text. So this is usually used to like run two programs at the same time, like a server and a client, for example. Some other useful syntax is like, so okay, these things are called jobs lah. All these things that are running in the background. And if you type in the command jobs, you can see all of the various tasks that are running in the background. And if you want to bring a corresponding task that's running in the background to the foreground, you can just use the FG command. Oops. Sorry, FG command. And you can also push a currently running program to the background with the BG command. There's some other useful things when it comes to controlling these kind of processes. So there's PS, which lists all the running processes. PG grep, which is very similar to grep, except it searches all the running processes by like string searching lah. So you can search for a specific name that you want. And finally, like I showed you, you can also end a specific background job by running the kill command, which will just end it for you. But you need to know the ID, which is printed when you first started it. So as mentioned, you can use the kill command. So if you're completely new shell, there are a few resources here. Later we'll put the link to the slides and you guys can take a look again. Okay, actually with that, there's a few other miscellaneous stuff I'll cover quickly. So sometimes piping doesn't always quite work because the command being piped into does not expect like a new line separator format. So for example, there's this file command that'll tell you the properties of a specific file. Okay, so let's try running it. So run file. So if I try running ls, okay, so basically file, I can use it to get the properties of any particular file. So for example, I could do file list test.sh, which is just basically say, oh, it's an ASCII text file, sure. Now you might want to think that you could pass in ls into list test, sorry, into file, which you would think would give you the output of every single file. But actually, it doesn't really work lah. And the problem is that the output of ls has new lines, which is not like, it's not able to be passed by file. So instead what you do is you have this command called xargs. So ls xargs file. Oops. Gotta make a typo. Okay, that's strange. Not sure why it's not working. ls xargs file. Did it work?
Yeah.
Okay, I don't know. Okay, you guys can try this. It should run on your laptops. I don't know why it's not running on mine.
Can you type file space something? No, just the command file.
Yeah, it works. Okay, but anyway, okay, the idea I'm trying to make is like basically ls would print out a list of files which cannot be properly passed by the file command. So when you use X args, it takes a list of arguments and a list of arguments printed by ls, for example, that format with the new lines and stuff, and it formats it properly for the file command to be able to like actually ingest it. I'm not exactly sure why it's not working on my laptop because I tested it yesterday, but
Wait, ls?
Oh. Oh.
Okay.
Okay.
Yes, good catch.
Thank you.
No, you need to quote it. Put dash
Oh,
B in
oh,
quotes.
oh, okay.
Because it's
Yeah, yeah, okay. Oh no.
back.
Okay. Okay, now it works. So, okay, thank you for that. So basically, okay, like I mentioned, so ls itself gives you like this sort of output, which which cannot be ingested by file. So when I do xargs, basically formats the output of ls in a way that file can accept it. So you can try it. ls is not the only command that it does like this, but you can try it for other things as well. Okay. Okay. There's also this thing. Okay, so this like curly brace notation might look weird, but basically what it's saying is make all permutations of AB and AB and AB. So basically take the first element and then map it to all the two elements in the second set. Take the second element and map it to two elements in the second set. So it'll be like, so get AA, AB, BA, BB. So okay, let's just try this. Yeah, I'll just go make a new directory so we don't have a lot of files. So touch A, comma B,
The space.
Oh,
comma
sorry.
B. The backslash.
Okay, sorry, let's do that again. Okay, so if I do touch A, comma B, then I do ls. Basically, you see how I have like every permutation of the files now. Okay, these ones were from before, sorry, ignore them. But essentially what I did is I created A, B, and so on and so forth. Okay. Another important thing is the T. So it was briefly mentioned just now, but basically sometimes you wanna pipe your output to a specific file, but you still want to see the output in your standard in. So you essentially want to create a copy of the output. So in that case, you can use T. So let's try this. Echo hello T. So if I did echo hello.txt.
T E E.
No, without the T.
Oh, okay. It won't work. Are you trying to pipe it into the file?
Oh yeah, sorry. Yeah.
Arrow. Yes.
Okay, so if I do something like this, then there's no output in my standard output. But if I open my hello.txt, so if I do that, then I can see that the output was piped here. But if I wanna, in some cases, you wanna also see the output in your standard output as well. In which case, you can use the T operator here. So in that case, I could do something like echo hello. T hello.txt. So in that case, I want to see that hello was still printed. If I go into hello.txt, it'll also be printed here lah.
I'll just say something really quickly, right? Something very useful about this operator, this parentheses operator, right? Is assuming you have hello.txt, right? And you want to quickly rename it to something. So you've got hello.txt, right? You can do something like this. So hello.txt into .back. So now that rename the file from hello.txt to hello.back. If you want to like make a backup of something and you want to edit it back, you can do hello.back to .txt. It even works with like, yeah, so if you want to like rename it like hello.txt.back, you could just do this comma dot back. And that'll move the file to hello.txt.back. Super useful if you want to like quickly rename something. Or instead of MB, you could copy a file to a backup file or something like that. Yeah.
Yep. One final cool thing is that like, so as mentioned just now, if you do the echo hello, then you pipe using the arrow operator to hello.txt, then it just replaces the content of the file with hello, with the output of the echo command. If I instead use a double arrow, basically what you do is you instead append to the file. So it's a minor difference, but it's something that's useful if you guys need as well. So I think with that, that's about the end of our workshop.